Welcome to the quick recording on how to collect the data for our TDA heat transfer lab, which is what you're looking at right now. And so here's the top of the document. We have the introduction, which we will read through in class together today, actually. There's background equipment information. Again, we will read together in class. Pre-lab questions, which we will do together in class. And then we get to the purpose of the lab, which is to determine if different materials have different rates of conductivity. Our hypothesis, if different materials are used, then the rate of conductivity will be different. And we are also collecting our data in Gizmos again. So to get to Gizmos, you're going to open ClassLink, click on your Gizmos app, and this time the lab is called Heat Transfer by Conduction. You're going to click on that and launch the lab, which I will share with you here in a second as well. And then underneath, this is our data table. So we're going to have 4 different materials, and we want to basically test to see how conductive they are using thermal equilibrium. So attaching 2 beakers by these materials and see how fast they could reach the same temperature. And so once we're in there, we're going to take the starting temperature of beaker A, the starting temperature of beaker B, the temperature at thermal equilibrium, and the time it takes to reach thermal equilibrium. Also note, and I'll share this with you in the lab in Gizmos as well, that the glass material is not going to ever reach thermal equilibrium because the Gizmos simulation only goes for so long, which is 137 minutes. And I guess I'm giving it away that glass is not a good conductor. So it takes a long time to reach thermal equilibrium using glass. And so we're just going to write down the time and the temperature that the simulation gives when it times out. All right, so I'm going to make this a little bit smaller and click on Gizmos. And so what I did here, actually, let me go back to the beginning so you could see. Okay, so I went into ClassLink, I clicked on Gizmos, which is right here, and when I did that, I came up to this home page, and this time, again, we are looking for, I guess it's not on mine, it should be on yours though, heat transfer by conduction. So that's the lab that we're going into. And I'm going to launch the lab by clicking on the rocket here, or I can launch the gizmo over here. So I'm going to click on that. And this is the only screen you need to look at. If you want to take a look at the other tabs across, you can, but this is the only screen that we need. So I'm going to make this a little bit smaller so we could look at the lab document and this at the same time. But for aluminum here, which is our first material, you could change the material here. So I'm going to stick with aluminum first. Beaker A starting temperature, so here's beaker A, is 95 degrees Celsius. Beaker B starting temperature is 5 degrees Celsius. I'm going to type that in, 5. And now I have to figure out what the temperature is going to be at thermal equilibrium and the time it takes to get there. And so all you have to do is click this arrow here at the bottom, and then you're going to hit the pause when they reach the same temperature, which is thermal equilibrium. And usually the system slows down as it gets there, so it should be pretty easy to pause it at the right time. So here we go. I'm going to click the forward arrow, and you can see beaker A's temperature is going down and beaker B's temperature is going up because heat always flows from hot to cold. We're getting close. It's slowing down. And right there, you could see they are now at the exact same temperature of 50 degrees Celsius. And it took 24 minutes and 10 seconds to get there. You could see, let me see, move that up a little. You could see at the bottom, it tells you the time. And so I'm going to go back and put in 50 degrees in the data table and also 24 minutes. So you could just round and use the minutes. You don't have to put the seconds into the chart. So the temperature was 50 degrees Celsius and it took, what did I say, 23 minutes? Let me look, 24 minutes. And that's it. And so we've done aluminum. And now I'm going to hit the arrow. Oh, I'm sorry, you have to reset first. Hit the arrow and move to copper. So the starting temperatures are the same. You could just write them down, beaker A, beaker B. You would hit the play button and again, write down the minutes and the thermal equilibrium temperature. And that's it, go through each one. Like I said before, when you do glass, it's never going to stop. Well, actually, the temperatures won't reach thermal equilibrium. The system will stop. The gizmo system is going to stop. So like I said, you could just write down the time in minutes that the system stops, knowing that they're not going to be at the same temperature. And as far as temperature is concerned, you can just choose, here, let's play. So you can see here, it's going really slow. We're still at 93 degrees and only 6 over here. And so this is going to go for quite some time, so I'm going to pause it. Whenever it's done, you can choose the temperature. It's up to you. So you could pick something in between wherever it stops, or you could pick beaker A or beaker B's temperature to write down in your data table. And we'll talk about that in class as well. And that's it. So once you have your data table filled out, you can move to the next part. If you have any questions, please let me know.